Bismillahirrahmanirrahim. Dear students, today we will address two queries before exercise 1.1. The first one is regarding the order properties of the complex numbers. We have discussed various properties of complex numbers in our previous lecture, but today we will discuss that the complex numbers does not satisfy the order properties. In our previous classes, we discussed the details regarding the order properties of real numbers, but in case of complex numbers, there are no order properties that are to be satisfied by the complex numbers. So the set of complex numbers does not satisfy the order properties. In fact, there is no sense in saying that one complex number is greater or less than the other. The second query is that how we can derive the formula for finding the multiplicative inverse of a complex number. How to find multiplicative inverse formula फॉर ए कम्प्लेक्स नंबर. हमने पिछले लेक्चर में ये चीज़ डिस्कस की थी कि मल्टीप्लिकेटिव इन्वर्स जो था उसको हमने किसी कम्प्लेक्स नंबर के साथ मल्टीप्लाई किया था तो हमें मल्टीप्लिकेटिव आइडेंटिटी आंसर मिल गया था. यानी हम मल्टीप्लिकेटिव इन्वर्स उस फार्मूले के तहत फाइंड आउट कर सकते हैं, लेकिन क्यूरी ये है अब के मल्टीप्लिकेटिव इन्वर्स का वो जो फार्मूला जो हमने कम्प्लेक्स नंबर के साथ मल्टीप्लाई किया था वो फार्मूला हम डिराइव कैसे करते हैं. तो हम डिफरेंट मेथड से डिराइव कर सकते हैं. मैं इसको अलजबरा के मेथड से करता हूँ. यानी हम फ़र्ज़ करते हैं लेट एक कम्प्लेक्स नंबर है a प्लस आयोटा b, देन हम इसका मल्टीप्लिकेटिव इन्वर्स z इन्वर्स लेट कर रहे हैं x प्लस आयोटा y है, सच डैट z multiplied by z inverse is equal to 1 plus iota 0. यानी किसी भी कम्प्लेक्स नंबर को उसके मल्टीप्लिकेटिव इन्वर्स के साथ जब हम मल्टीप्लाई करेंगे तो हमारे पास मल्टीप्लिकेटिव आइडेंटिटी आंसर आएगा. तो मल्टीप्लिकेटिव आइडेंटिटी हम ये स्टडी कर चुके हैं प्रीवियस लेक्चर में कि एक ऐसा कम्प्लेक्स नंबर है जिसको हम किसी भी कम्प्लेक्स नंबर के साथ मल्टीप्लाई करते हैं तो उस कम्प्लेक्स नंबर में कोई फ़र्क नहीं पड़ता. तो z अगर एक कम्प्लेक्स नंबर है और z इन्वर्स उसका जो हमने फ़र्ज़ कर लिया है मल्टीप्लिकेटिव इन्वर्स है, अगर हम दोनों को मल्टीप्लाई करते हैं तो मल्टीप्लिकेटिव आइडेंटिटी इसका आंसर आएगा. सो नाउ वी प्रोसीड फॉर डिराइविंग द फार्मूला. z इज़ इक्वल टू a प्लस आयोटा b and z inverse is equal to x plus iota y. This will be equal to 1 plus iota 0. So we will multiply to get ax plus iota ay plus iota bx plus iota square by is equal to 1 plus iota 0. Since iota square is equal to -1, so we will write here ax plus iota taking common ay plus bx, this will become -1 into by equal to 1 plus iota 0. So we will combine the real parts and imaginary parts. Ax minus by, this will be the real part of this product of two complex numbers, and this will be the ay plus bx will be the imaginary part of the complex number. We have studied in our previous lecture that two complex numbers are equal if and only if their real parts are equal and their imaginary parts are also equal. So this implies real parts of both the complex numbers are equal. This should be equal to 1. the real part of this complex number is 1 and this real part of this complex number is ax minus by. So in order to become both the complex numbers to be equal, the real parts of both the complex number should be equal. Ax minus by is equal to 1. Similarly, the imaginary part of both the complex numbers should be equal, and ay plus bx is equal to 0. So this is equation number 1 and this is equation number 2. We have to solve both the equations using algebraic methods approaches to find out the values of x and y. So we can use the substitution method from 1. Ax is equal to 1 plus by, and x will be equal to 1 plus by over a. This is equation number 3. Equation 2 becomes, we are using the value of x in equation number 2. The value of x has been derived from equation number 1. This is called substitution method. Ay plus bx is equal to 0. So we will multiply by a on both sides. This will become a square y plus, if you multiply a with this term, then a will be cancelled with that a. So we will get b into 1 plus by equal to 0. A square y plus b square y equal to 0. If we take common y as common, y is equal to into a square plus b square plus b is equal to 0, and y will be equal to, this will be minus b and this be over a square plus b square. This is value of y we have found using the substitution method. We will put up this value of y in equation number 3 to find the value of x. So using value of y in equation number 3, to get x will be equal to 1 plus by over a. So this will become 1, if we take the LCM, a square plus b square, then it will become a square plus b square minus b square, and this a will become 1 over a. So we will get x equal to a square over a square plus b square, because b square will be cancelled by the minus b square. So when b square is cancelled by the minus b square, then a square and this a will be reduced to a over a square plus b square. So hence we will use the values of x and y in the original supposed inverse of the complex number, that is equal to z inverse equal to x plus iota y. So we will write x mean for a over a square plus b square plus iota y. So in order pair form we can write it as a over a square over b square, and y coordinate or imaginary part of the complex number will be a square plus b square. So this is the formula we have derived to find out the multiplicative inverse of a complex number in coordinate form, in order pair form. Dear students, now we will solve the first question of your exercise 1.1. that is about find the multiplicative inverse of the following complex numbers. There are three parts of this question number 1. The first one, let z is equal to -4 7. जो भी कम्प्लेक्स नंबर है हमने उसको z के इक्वल फ़र्ज कर लिया है. Then we have to find out the complex numbers multiplicative inverse. We have derived the formula for multiplicative inverse of a complex number z as z inverse equal to a over a square plus b square. This will be the order pair form, and this is meant for x coordinate a over a square plus b square, that is real part of the complex number, and imaginary part as minus b over a square plus b square. So we will use this formula directly in the question number 1. We know that a is equal to -4. This implies a is equal to -4 and b is equal to 7. We know that z inverse is equal to a over a square plus b square and minus b over a square plus b square. We will put the values of a and b to get -4 over -4 square plus 7 square minus b over a square plus b square. We will simplify it. This is the required answer. You can counter check this answer by multiplying the complex number with this multiplicative inverse. You will get 1 plus 0 iota, that is the multiplicative identity, as the answer. So this is all about the first part of question number 1. The second part of question number 1 will be same. We will let z is equal to 2 under root minus 5 under root. This implies a is equal to 2 under root and b is equal to minus 5 under root. So we know that z inverse is equal to a over a square plus b square minus b over a square plus b square. So z inverse will be equal to a square plus b square so z inverse will be equal to 2 under root over 2 plus 5, and this will be equal to 5 under root, minus minus will be cancelled, 2 plus 5. So we will get it equal to 2 under root over 7, 5 under root over 7. This is the required multiplicative inverse of the given complex number. Now the third and last part of question number 1, we have to find the multiplicative inverse of 1 0. 1 plus 0 iota, or in order pair form this is 1 0. 1 is real part and 0 is imaginary part. This is the multiplicative identity, and we will see that the multiplicative inverse of the multiplicative identity is the multiplicative identity itself. For this purpose, we will let z is equal to 1 plus 0 iota. This implies a is equal to 1 and b is equal to 0. We use the formula z inverse is equal to a over a square plus b square minus b over a square plus b square. By putting the values of a and b, we will get 1 over 1 square plus 0 square and minus 0 over 1 square plus 0 square. Then this will become z inverse equal to 1 over 1, and this will become 0. 0 something is 0. Hence z inverse will be equal to 1, 0. So the multiplicative inverse of multiplicative identity is the multiplicative identity itself.